Alrighty, so have another problem here. We're looking at insert interval on LeetCode, and I guess we'll get right into it. So there's a kind of I want to say I dreaded this problem, but I've seen this problem before. I actually like skipped it a while back. The reason I want to look at it is I actually probably I'm probably gonna come up with like a suboptimal solution, and then like maybe it's been a while, maybe I could think of something that's reasonable, but I'll probably come with a suboptimal solution and then look for and then probably look at the discussion and see what they have to say, because I think I've kind of like conceded the point that like these problems you really do need to just like read a lot. Like it just takes too much time to try to think up a much better solution on your own. If you know the solution offhand, then it's not too bad. But trying to like sit there and think about like the most optimal way it just takes forever. That's my experience. I've been working on these problems for like many years. It just takes so much time. It just takes so much. Excuse me. You don't know the answer offhand. It'll take forever to find like the best way to do it, or it could take forever. All right. Array of non-overlapping intervals. Intervals of I, start of I, end of I represent the start and the end of the ith interval, and the intervals sorted in ascending order by start. You're also given interval new interval, represents the start and end of another interval. Insert new interval into intervals such that intervals is still sorted in ascending order by start of I, and intervals still does not have any overlapping intervals. Merge overlapping intervals if necessary. Return intervals after the insertion. Oh. Huh. Oh, actually, this might not be as hard as I thought. I've seen this question before, but this actually might not be that hard. 13692515. Oh, okay. So you just merge the interval. All right, that's actually super easy. So I think it's really easy. I think you just do like a lower bound search on the intervals, and you compare the intervals by their starting interval. I want to say, is that wrong? Is that right? I don't know. Because this starting interval has to start before the next starting interval. Is that right? Actually, well, how many intervals do you merge with? Actually, that's a question. I'm not sure. I'm thinking now. I guess actually it's the other way. Probably the other way around. Like probably just the ending. Use as sort of the key, and you just say that. So I think you do logarithmic time. You do this. You just find the first starting interval. The starting point is before the ending of the interval you're going to insert, and then basically merge any and all intervals to the left that you need to with your interval. Excuse me. So now here's a tricky thing. There might be more than one interval that you have to merge with. In order to figure that out, you would, I guess you would do another search with the your starting point, and what would you merge with though? And actually also inserting into the middle of all of this. I don't know if you could do that in logarithmic time, because it's the tricky thing with that too is like, well, I guess you could just return, like just do in linear time and return the whole interval, all the intervals in one just block. Yeah, I guess that's fine. I'm just excuse me. I'm just thinking, because this vector data structure isn't really made to insert at arbitrary positions. That's what I'm trying to say. Like you can't just insert an interval right in the middle and do that in constant time. You need a different data structure. So yeah, I guess it's okay. Fair enough. So that's fine. But my question would be like, I guess you need to find the beginning and ending part of the intervals that you're not going to merge with. So I guess what you would do is all the intervals. So there's a set of intervals to the left of your starting point. So all of those ending points are to the left. And actually, you could do this in linear time. You don't have to do a binary search, because if we're going to rebuild the intervals anyway, I guess we could do it in binary search anyway. Well, I don't know. We could, yeah. If we're going to rebuild the interval set anyway, that's linear time in the worst case. So we could actually just loop over all the intervals if we wanted to. There's not a lot of them anyway. There's only 10,000 of them. So is that right? 10,000? Yeah. So, huh. Okay. So let's think about this then. We want the interval. We want to search for the interval on the right side. That's the first starting interval that's larger. So it would be the lower bound, larger, right? Not the difference between the lower bound and upper bound is lower bound is larger or equal to, and upper bound is larger. So actually, no, not the. That's interesting too. Actually, think about that. So, would you? Oh no, that might not be right either. Would you merge with? This is kind of tricky. I'm thinking about it. Do you merge if you see an interval and your ending point is equal to the starting point of that interval? How much do you merge with that interval, and how much do you merge with that interval? I think you do. You do merge with that interval. You merge with the whole thing. Yeah. That ending part of the interval becomes part of your, yeah. So no, we do want the upper bound then. We want the upper bound, and it's going to be the upper bound using the starting points. Yeah. Upper bound starting points is the first starting point that's larger than your end point. That's going to be the right side. So everything to the right you're not going to touch, including that one. And then on the other side, you want your ending points to be smaller than your starting point. So the first ending point that's smaller than your starting point, that marks the left side. Everything including the left of that, you don't include into your interval. And everything in between, excuse me, actually you still could do this logarithmic time, I guess. Everything in between basically would get replaced with a, everything in between would get replaced with a, Sorry, I'm just thinking about this here. It's a tricky thing. Everything in between would get replaced with a larger interval. It would be from the right side, the left, the first element on the left, you'd have the endpoint. You want to take the maximum of the endpoint and the endpoint you're inserting. That's your new interval's endpoint. And on the left side, one to the right, the minimum of the new element the starting point that you're inserting, and the starting point that's on that sort of next element on the right side, on the left side to the right, one. If there was one that exists, if there's anything even in that. Obviously, if we're empty altogether, then just the interval we're inserting is all we're going to insert. So we want to remove all of those elements. So then you would say everything from left to that point that we're including, we said, if it exists, we're going to, I guess we do just create a new interval array and return that. So let's do that. That's probably the simplest way to do it. So this is an interesting question too, and I guess like calming down a little bit and taking these a little bit slower is fine. Like I said, I'm kind of irritated, so I'm going a lot slower than I should, or a lot faster than I should, and not being as careful as I should. But yeah, so the thing about the upper bound and the lower bound though is oh no, I didn't mean to click that. That is clearly not what I wanted. That was some other. Hopefully, I didn't get hacked. Some other website. How are we doing on time? Yeah, 10 minutes. Okay. All right. Compare. That's what we want. We'll write our own comparison function. So the value, yeah, so let's try that. So let's try to get our upper bound. And so we have an upper bound. Now the tricky thing is the lower bound. So the upper bound is fine, right? That's pretty easy. We get the first interval pointer to we get a pointer to the first interval that's larger, or if it exists. Excuse me. Tricky thing here though is on the other side, the left side, the first interval that's less than our starting point, that the ending point is less than the starting point, that is not quite what we want. Our lower bound isn't going to give us what we want, because the lower bound gives us less than or equal to, and it's actually like the direction is wrong, I suppose. Like we're trying to get something smaller rather than larger, and so I guess our comparator, I think we want to reverse the comparator, but then we also kind of need to reverse the direction that we're going in also. So I'm wondering if we want to actually still use upper bound, but we're gonna look in the reverse direction, and we're gonna use a comparator that's inverted. So instead of greater than, it's gonna be less than. Let's try that. See what happens. So standard. So we want to say auto right bound. We can just say A and B, but right bound. Well, let's do, yeah, we can do auto A and B, why not? All right, so A is the one where things are going to be inverted, so let's not do that. So we want to do upper bound of intervals, begin intervals dot end, and then we want to say our target is going to be, we have our new interval, so we'll say, let's say just const auto xy is going to be our new interval. Actually, I don't know if we can do that. Yeah, I don't think we can do that. I think this needs to be a tuple if we want to do it that way. And y. Okay. So, okay. And we want to say now intervals end, intervals. So the comparison function kind of matters a lot, though. That's a tricky thing. So we want to, you can, type 1 and type 2, it can be, it's an integer, and and Boolean is the forwarded, type 1 forwarded with dereferencing, implicit converted type 1. T can be type 2. Oh, what's T? Wait. Yeah, okay, so so you're actually, A is going to be, okay, got it. So A is going to be the interval, or just X, and then int is going to be, or T, I guess, target, something like that. So I'll explain shortly what's going on here. So we're at a lambda function, and we want to, excuse me, what we want to return is this particular target, and the key we're going to use is end or y, right? So we want something that's larger than y. So we're going to do less than. We're going to do y is, or the target, and the way to use less than, it's actually going to be x of 1 less than target. So that's going to be a little confusing, but if we dereference b, we say, let's try something like, You could do like standard cout b dereference b of 0, and then b dereference 1 standard line. And we want to say just values. Just label them something. And let me just return nothing here for now. I just want to test and see what this gives us. 16 minutes in. So, excuse me. What I want to do is just test that this works the way I think it works, because using upper bound sometimes could be a little confusing. And on our test case, we have 136925. So we should see 69 printed, right? That's what we want. Ideally, that's what we want. It's not a function or function pointer. Oh. I forget sometimes. Get a little bit ahead of myself. Compiler error. Conversion from constant to constant vector for first argument. Did I misunderstand this? Type 1 such that an object of type forward integer can be dereferenced and then implicitly converted to type 1. That's fine. Type 2, type t can be converted to type 2. Right, t is our value, right? So t is our integer. So the first value, is upper bound the other way around? Is that the issue? Is upper bound, is it the other way around? Is that why? Is that the issue? Is that why? Type 1. Oh, that's interesting. So type 1 goes the other direction. Oh, wait a minute. Do these not do what I think it does? Not value less than element and element less than value. If you swap these two, you say element less than value or element greater than value, and then not element greater than value. It means elements less than or equal to value. Yeah. So actually, these really shouldn't be swapped. That's interesting. The comparator goes the other direction as well from lower and upper bound, which is a little confusing, but a little bit disorienting, I guess. That's fine. Okay, how do we do? Runtime error, okay. Okay, which one is that? Is it this one? Is it this one? Let's see, which one is the runtime error? All right. It's definitely one of these two, which I guess you kind of assume that, realize that. Okay, but that's not, so it wouldn't necessarily be a problem, except it looks like we weren't able to get what we wanted. Ah, okay, I see the problem. Yeah, you can't dereference this. But that's not what we want. We want y is, y should be 5, and so we want this interval over here, 6, 9. So we want upper bound, left to right. Target is 5. This vector x, we're going to say, actually it should be x0. And we're saying the upper bound is right. The upper bound is the first time that we're larger. Well, 9 is definitely larger than 5. But we're using, so it's interesting that we're using less than. It should be, the default I think is less than, or not. Oh, dude, this is so confusing. This is when the element's less than the value, lower bound. I thought lower bound was on the other side. The lower bound will be to the left of the upper bound. That's really confusing. Why is, huh? Yeah, no, not less than. Yeah, not less than. That's fine. And this is greater than. So we do want upper bound. It's greater than. Yeah, perfect. So confusing. First version uses less than, second version uses a given comparator. Yeah, it should be less than, but A less than B or B less than A. I think it's position, it's not oh, I see, that's confusing. That's very confusing. So, the comparator gets swapped as well, which is so weird. That's so annoying. I think it's supposed to be this way for upper bound. Otherwise, it doesn't work the way you'd expect. Yeah. So, it's so confusing. I don't know. I'm like debating whether or not I should keep trying to use upper bound, lower bound because it's way too confusing. Yeah, that's what I'm saying. Yep. That is the most confusing thing ever. It works in a totally different way than the comparator that it uses in upper bound is less than, but it compares them in different directions. It uses this x as its, yeah, it does this. It does target less than x0 rather than x0 less than target. And that what's interesting about that is it makes the what's interesting about that is it makes the what's it saying? What's interesting about that is it makes the targets less than 0. What's interesting about that is it makes the truth values are swapped. So like the lower bound, I guess, would operate. I guess both of these are coming from different directions. Maybe that's how it works. But the lower bound, you would have x0 on the left side and target on the right side. It would still use less than, but it swaps the two. So that's super confusing. But okay, interesting. So yeah, now we want to find. We actually do want to use we want to use upper bound in the other direction. We want to do reverse. Begin reverse end. We want to use X. These are now going to get swapped. And this gets swapped. This is one of those things that like I would never remember. If I had to remember this, I wouldn't remember it. And then now, excuse me. Now what happens is, and now it wouldn't work the way we'd want it to. Like we would have to use for our test, we would have to use something like 1, 1 or 1, 2, make this 3, right? Also, the intervals themselves could be a start could be equal to end. How are we doing on time? 24 minutes. All right, not too bad. What could happen is we could do a similar thing here too. Oh, well, this is really interesting. Oh, yeah. So we reverse end, and then check X, and then here we want to do A and A. So now you have to use reverse. It's a reverse iterator. Now things are sorted in descending order. we want to perform the same routine, but in the other direction, also looking for the upper bound. What's tricky about this is both of these get swapped. This now, but now we're going in reverse. This actually, we want this to be greater than, which is even now very confusing. And I don't know if this will work properly, but we'll find out. Okay. No matching function called object lambda constant. Is this? Am I crazy? Am I losing my marbles? Oh no, because it's still the upper bound. If it was the lower bound, it'd be swapped. I'm sorry. So actually, this is still. Yeah. All right. I'm losing my mind because it is still the upper bound. The lower bound. It's actually the upper bound. It's actually still this, and then this gets swapped. So much swapping going on here. Oh, look at that. 1269, 1369. But the ladder actually should have caused a problem. We don't want that. Yeah, we don't want that. That's an issue. Oh, because this is supposed to be x1 now, not x0. These should be else statements. Otherwise it'll crash. Yeah. Okay, how about this? How about this? Yeah, there you go. That's what we want. That's what we want. Okay. So everything to the right, including B, is going to be the intervals that we append, and everything to the left and A, including A, is we prefix. So this is the B into the right is the suffix, A into the right is the prefix of what we're going to return. Excuse me. And everything in between is going to be the. It's actually not even going to be everything in between. We can do. Well, yeah, everything in between is going to be the. Is what we make our new, what we update our new interval with. So we can say, yeah, we could do that. So prefix the intervals, prefix intervals. I'll just say it that way. So for auto pointer p equals a, or actually it would be intervals dot begin, and then you would say p is not equal to a plus p, and actually it's reverse begin. No. So what's interesting is this is actually going to go. Oh, actually, I don't know if this is what we want to do. We actually want to go from A. No, this is really interesting. From A to reverse begin, or reverse end rather. Intervals, reverse end, and we say ret dot push back A. Suffix intervals. Same deal. P equals B. P is now equal to intervals end. Push back P, not A. Increment P. And then return ret. And we'll say build new interval. And now this depends on all of the excuse me, all the intervals between A and B. Actually, I don't know if we can do that. Now I'm thinking about it. Well, all you need is the previous interval. So for yeah, actually I don't know. That's tricky. if there is one. Excuse me. So you could be in a situation where there is no. Well, this could be all right. So we could do. So we could do. You could decrement. So if a is not equal to intervals dot begin dot r begin. So here's the tricky thing. You can always decrement a, but as long as it's not the beginning. I guess we also assume that we already always have intervals to work with in the first place. So if we're not at the beginning, then we could do a decrement a, and say, or not decrement a, but say auto const auto p equals a minus 1. Let's try that. And then we can say something like and it's going to be y, so we say new x, new y. Let's do it that way. So a is going to be on the left side. I'm going to go 1 to the right if it exists, and we're going to update new x is equal to standard minimum of x, or new x, and if you dereference p, you can get the minimum value 0. And the same thing, build new interval over here. On the other side is b, as long as b is not in the beginning. So all the way on the left side, we want to decrement 1 as well. Take the maximum of new y, and it's going to be new y and p, and it's going to be on the, so a is on the left side, b is on the right side. A, we're going to look to the right, and b, we're going to look to the left. And a, we're looking for the minimum value, so 0 at the first of the interval, and on the right side we're looking for the second value, the larger value, so 1. And then we update our new interval with our new interval is going to be new x, new y. That's sort of combining all the intervals in between. And all you have to do is insert interval. And we're on our way. I think this should do it. Bit of a doozy of a question though. How are we doing? 33 minutes? Wow. It's quite the problem. We should test some test cases though. We should actually use all the example test cases. Oh, there's 5 of them. Nice. Should we just go for it? I'm tempted. Yeah. I gotta stop doing that. That's not a good habit. That's not a good habit. You want to test it a little more. Yeah. So. Tempted and tried, I wonder why the good man died. Jesus Christ, 'cause he loves them both. Question here, how are we doing? 34 minutes, okay. Excuse me. Okay, I think we're ready to submit, but the tricky thing is we want and we got I wanted to check if new interval length. Yeah, new interval always has something in it. All right, I think we go for it. I don't know. I think we're fine. No. Oh. Of course. Oh. I don't know. I was thinking. That was my fault. I'm way too excited about this. I don't know. Like this. Oh. Oh yeah, this one. Yeah, this is empty. It works if it's empty. Why? I guess we just didn't handle the case where we add something to the end. Really? Why though? I don't know, man. I'm way too trigger happy when it comes to these problems. There's too many cases to work around, to think about. So you're telling me, oh, whoa, uh-oh, oh, ooh, wait a minute, wait, wait a minute, wait a minute, wait. Oh, these are being added in reversed order. Ooh, I didn't think about that. Oh, I could just reverse it. That's fine. That's actually not that hard to fix. Yeah. Yeah. Okay. That's fine. That's actually not that big of a deal. But um, about that. Well, I guess that's pretty subtle. I don't know. This is so confusing. This is such a confusing problem. I guess it's okay, but it's really annoying because you can't get the interval easily with the upper bound because you end up with it's in the reverse direction, so now you're inserting your intervals in reverse, which is annoying. Like, what if you wanted to convert this to an iterator that's not a reverse iterator? I guess what you could do is, like, there's another way to do this that's probably better. It's probably a little bit faster. So you could say, build an interval. So we're going to say int I equals intervals dot, or it's going to be a minus intervals dot r begin. Something like this. So what you do is you have the index from the right, and then we say int, call it a, I don't know, a2. We can say that's now intervals dot begin plus, and we can say intervals dot size minus I, right? So now I think minus I plus 1. So, excuse me. So if 0 is all the way where interval size minus 1 is, right? Actually, maybe minus 1. Yeah, if interval size minus 1 is where 0 is, and then we want to move to the left and have our index is going to be interval size minus 1. Not sure how to express it. From right to left, our index is 0, where the left to right index is n minus 1. And then on the other side, you want n minus 1, and we're gonna traverse, right, from one to the other. I guess the way to do that is if you have from 0 to n minus 1, then on the other side, 0 to n minus 1 on the other side would be, you would subtract Is it the other way around? That's also, yeah, okay. N minus 1 minus the other, yes, n minus 1 minus the other interval value, yeah, which is exactly what we're doing here. But that would give us something kind of interesting. That would give us I is, so this whole equation looks like this. I is a minus interval begin, so you get minus a plus interval begin, right? Something like this. And you add all that together, so it looks kind of crazy, but yeah. But you can do this to get things into a different state. And now you can say a2, and it's not an integer anymore, by the way, that's a pointer. And now that's not, and you actually want to say, oh no, take this point, go back. Hold on, I did this wrong. Wait. Hold on a sec. Excuse me. Hold on a second. Could go all the way back. All the way back. Okay. If we wanted to do this, we could say a2. Now we can say p equals intervals dot begin, and p is not equal to a2. And actually, we wanted to add 1. You actually add 1 here, and now you don't need to reverse this anymore. Hopefully that makes sense. Hopefully that makes sense. Nope, runtime error. Nice. And this is non-zero. This size minus 1 minus 0 plus begin, this is non-zero. But this could be actually, what's going on here? Wait a second. What? Well, let's try. Oh, you know what? Actually, no. I'm not sure. What is going on now? A is a minus interval r begin. That gives our index on the left, from right to left. I want to convert that. So we would subtract size minus 1, n minus 1, minus that value. So let's say if there are 5 elements, it'd be like 6 elements would be 0 through 5. Size is 6. You subtract the index. Let's say the index was all the way on the other side. It was 5. So you do 6 minus 5 minus 1, 0. Intervals begin at 0. Yeah, so I think you actually include, but why is this a problem? What's going on? What's happening? This actually shouldn't be that hard to do. C1123. And my feet are killing me. How does C end up back at 1, by the way? Where does that, what? Something weird is going on. Man, I don't know. Programming's crazy. How perfect do I need to be? How perfect do I need to be a developer, you know? But there should be a way to convert this back, so we don't need to reverse. Okay, and then if we get rid of this one, right? Excuse me. This is the one that's causing the issue. Yeah. So. We get 1, 2, 3, and then we have a problem, right? Well, A2 is what is this number here? Like when we print this? Okay. I see. That's a pretty large number. And how did that happen? What? That's not right at all. That's not the right number. What? Huh? Do you go the other direction? I don't think so. What is I? What? Pretty sure. How are we doing? Oh, that's not what I meant to do. How are we doing? 47 minutes. Okay. I is 2. How? What is going on here? What? Excuse me. What? Oh, I guess it's underflowed, and because it's an infinitely large. Oh, I think I see. Understand what happened. Okay, that's kind of subtle. It really should be. But no. This is an integer. But the problem here is. I see. So it's giving us a gigantic. So it's underflow. This is an unsigned integer, more or less, or not even an unsigned integer, but just a gigantic integer. It's the largest integer you could possibly have, more or less, something like that. But the problem with this is there are. Okay, but no. But hold on. This is 0 indexed. This is 1 indexed. You subtract 1 to make it 0 indexed, right? Then you subtract I. So I guess what's being stated here is that actually you should add 1 to I because I is not 1 indexed. And you're subtracting something that's not 1 indexed from something that is 1 indexed. And that's why, and you're going to add 1 to I to make it 1 indexed. I think this is like a classic problem of like something that's 0 indexed compared to something that's 1 indexed. But if you subtract 1 from the interval size, that gives you, that is a 0 index. That's the index of the last value, and you're subtracting the index of. Okay, I need to sit down. My feet are starting to ache. This is kind of what I was worried about. I think the problem is that we're going off the edge, right? We're not. Yeah, that's the issue. We're going off the edge. So no. This shouldn't even be an issue. It's actually not a problem. We're here at 1,3. On the left side. Oh no, you're right. No, I'm sorry. There is nothing on the left side. There is no. Yeah. So we actually hit. It's not. It's our end. We're actually at our end, and the issue with our end is that our end is 1 larger. So this interval actually ends up being I see. No, we did this right, but the interval itself. So you can hit the end, and then you have an issue, because this number won't be correct. And then you're looking at intervals begin. That's very awkward. So you could just say something like the following. Yeah, no, this is fine. I was kind of thinking about that. I was like, what about the case where we go off the edge? What happens? So instead of a reverse, you could just say if a is not equal to intervals dot arb end, then we could do the following. Whoops, yeah, that's fine. Yeah, and now you don't need to reverse. I think that's all we need. Now, another issue here is I don't think this works properly, believe it or not. There's one more thing. There's one more issue. So the issue is that you don't end at the right spot. You end too early in some cases. So yeah, 1, 2, 6, 7, 9. We're actually just missing the 15, 18. Oh no, excuse me. We're missing the 7, 9. So this should actually be +1. Yeah. Yeah. And then it'll work properly. Hopefully we got it. I don't know if we got it. Oh, there we go. That's a lot faster. There you go. Super speedy. Super fast. Way faster, right? 2 logarithmic time routines to figure out, basically split this into 3 pieces, and then we can build the middle piece relatively easily, and then although the prefix we have to do a little bit of magic with our pointers to get the right index. Excuse me. But that works out in the end. Yeah. There might be a better way to do this where you don't need an if statement. It's kind of ugly with an if statement. But yeah, do some conversion in terms of the indices. That is so confusing. That conversion. Like if I had to do that, that'd be so hard. Programming is a struggle. Programming. It is a struggle. See what happens if we run it again. How do we do? 8 milliseconds. Nice. Let's go for one more. All right. I think that's it for this problem. We should look at the discussion. Yeah, the discussion always has something very concise. Straightforward Java, 7+ lines, 3 easy solutions, easy and clean, linear times C++. Everybody's got easy and clean. Oh, dude. This is so much easier than what I did. What I did was such a mess. What I did was so much harder. What I did was so much harder. Why is it so much harder? Okay. Alrighty. They changed this slightly too. It used to be interval. 2018. Result. Index less than size. Interval is index.end. New interval.start. We're going to push back all those intervals. Then we're going to update our start and end, considering all the intervals in between. I should have done that. That would have been so much easier. And then push that back, and then push the rest. Yeah. Oh, that's super clean. I don't know. I don't know what I was thinking, man. Because it ended up being linear anyway, so this is super easy. This handles all those uncomfortable cases too, all of the awkward cases. That's pretty easy. Yeah. So, okay. Duh. I don't know why I put so much effort in this. This is a bad idea. We're not gonna keep this. I don't know, man. I don't know. I don't know. It doesn't need to be that. It's actually probably faster we do the other approach. So we're gonna try again. Yeah. I mean, how do you know that ahead of time that you're gonna do something like this? I guess you think about it a little bit more. So x is 0, so we'll say 4. So we're gonna say as long as intervals of x and new interval. Oh yeah. Just a b. We're actually going to update a and b. So as long as intervals of x of, I guess, so the first one from left to right, we want from left to right, we want the intervals that are strictly smaller. So intervals of x of 1 are less than a. All those push in there. Now we're going to say for we're going to say int I equals x, I, and then there's an actually exiting condition. We're going to increment I. And you can actually just increment x, I think, all the way through, really. I'm thinking about it. I don't even need an I. You could just use x. And say now intervals of, it's the other side. So intervals of x, and another thing too. X is less than intervals.size. Same thing here. Now on the other side, it's intervals of x of 0 is strictly excuse me. Really, everything to the right, we want these to be larger. Or another way of putting it is this: as long as intervals of x 0 is less than or equal to, is it less than or equal to? Yeah, it would be. Hold on, we can think about this too. A and B. Really, we would want everything that's not greater than base, so less than or equal to B. Hold on. As long as B is greater than or equal to, that's so confusing. As long as B is greater than or equal to the at intervals A value, then we're going to do the following. Oh, actually these should be constants then. We're going to say new A equals A, and new B equals B. All right. And while that's the case, we're going to take the maximum or the minimum of new A and intervals of x of A or of 0. And then we're also going to say new B, similar. This is actually going to be the maximum of new B and the second value. And then eventually we're going to add that interval, which is just vector of ints, new A, new B, And then at the end, we're going to for x less than intervals dot size, and that's really it actually. Ret dot pushback. Just push everything else. Push back. Super simple thing, actually, but plenty of room for error, and I definitely made a lot of errors. I don't know why I didn't think of this to do it this way the first time. I think I wanted to be kind of fancy with my logarithmic searches, my binary searches, I guess. I don't know. Excuse me. Maybe it was faster to do it the way I did it first, though. The reason being is that all of these checks, you don't need to do as many. You could skip a lot of these. I think the way I did it the first time is better, technically. I think the way I did it the first time is technically better. This is fast to code, but it's not as efficient, and the reason is that the interval in the middle, you actually don't need to do this much work on the inner interval. It's the same asymptotic time complexity, but like if the interval you're inserting is very large, then actually this could end up being like logarithmic time if we did it the way that I did it originally. Yeah, so actually it depends on how big the interval is. This is good. This is not good if the interval is very large. This is about if the interval is very small, it's about the same speed. So that's interesting. So let's go all the way back. So I guess what I did the first time was right. So I guess I did what I was supposed to do the first time then. What happens when we run this? Is this the same one? Yeah. Okay. But not much faster. A little bit faster, but not much. A lot more work though. Yeah, I think it's kind of random actually, both of these. But no, I don't know. This is definitely faster. It's definitely faster. Yeah. Some cases it's not much faster though. Right? A lot of this seems to be like random. You just randomly roll something better or worse. Yeah, okay. Alright, anyway, so yeah, interesting question, fun question. Definitely probably not the best to try to use the upper bound, lower bound sort of dichotomy here to do this, because it just seems to take so much time. Excuse me. Also reversing. I actually got it wrong the first time because I forgot to reverse these. So yeah, tricky thing if you do it this way, but not that hard if you do it the other way. If you kind of just take all the ones on the left that are smaller, kind of group, take the minimum of the minimums, the maximum of the maximums, all the ones that you're gonna remove, and everything to the right. You just add at the end. Like that's super simple to do it that way. This is another approach that you can find in logarithmic time, the left and the right ends of the interval you're gonna insert, and then create the interval there, and then take everything to the left, everything to the right. So everything to the left, new interval, everything to the right, and do it that way. That's a little bit faster on like with the interval in the middle is very large, but that's actually not asymptotically faster. So you're better off really doing the easier approach, I think. Yeah, it's better off to do the easier approach. So anyway, so pretty interesting question. I'm going to take a break here. I think I'm going to get some food. I think tomorrow we're going to spend a lot of time programming. We'll do try to get like 12 hours in or something. Try to get a lot of time. I'm upset, man. I'm upset. I'm just upset. Programming is tough. Programming is hard. Programming is a struggle. It really is. Alrighty. Thank you for watching, and I'm going to head off now.